Let's talk about even mechanisms. So what is even reaction mechanism? Even is elimination and one molecule involved here. So let's just see what happened. The general form of even mechanism is as follows. The general form. This is the general form of even mechanisms. General form, yes. You can see this one, yes. Now we see more clearly. So you can see what's going on here. This is halogen group, okay, this leaving and base is coming. In the next step, what you see is when this leaves, it will be plus charge here on this carbon, and then base comes, picks up proton next to the carbons, and what can happen then if it picks up proton? We talk about elimination. This proton would not be here, then these electrons of this hydrogen will be used to form this bonds, a double bond. Let's see what happens. Yes, same thing happens. So was even elimination in the first step? In even eliminations, what happens? This leaves. Just leaves. Halogen is leaving group. It just leaves. We're talking about even mechanisms. Even mechanism. Okay. And what happened in the even mechanism? The first thing is halogen leaves, and halogens just leaves, and halogens leaves. There would be plus charge, because when halogen leaves, it takes up this electron with this guy takes electron. And what is leaves what leaves behind is carbon, which is now hungry of electron. Carbon, poor carbon has been robbed of electron. Halogen did not stay here and took electron. Carbon is no electropositive. There's really things which happen in carbon is electropositive. Now, how this carbon is going to get an electron? This will get from these electrons to another carbon. This has two electrons, which is forming bond with hydrogen. Hydrogen is being pulled up by this base. So base says, I have two electrons. Would you hydrogen come towards me and form a bond? Can you leave this carbon? Hydrogen says, okay, I can leave this carbon. That's fine. So when hydrogen leaves, hydrogen is not electronegative as halogen was. So when hydrogen leaves, it leaves behind electron. And this carbon get a chance of taking electron back, which it lost when halogen left in the previous reaction. So what happened here is these electrons form a double bond, and that's it. So you got double bond. That's winning guy. That's a very, very beautiful thing you get. This is what you got from even elimination. So this is the reaction. Now what happened? We go here. B is a base. We mentioned here B. That's base. Okay. X is leaving group. Usually halide or tosylate. So this is X. So that's leaving group. So we talk about even mechanisms. We talk further. We see what happens. What's this? Yes, in the even mechanism, yes, in the even mechanisms, and the first step is the loss of the leaving group. First step is loss of the leaving group. You can see this one was leaving group here. This one was leaving group. This one. So first step is loss of leaving group. Okay. First step is loss of leaving group. So when leaving group leaves, what happens? Leaves in a very slow step. Leaving group leaves, but his really slow step is slow, resulting in the formation. What happened when it leaves? Formation of a carbocation. Okay, wow. But when halogen leaves, carbocation is formed, but it is slow step. Okay, then what happened? Then attacks a neighboring hydrogen, forcing the electron from. So then what happened? Then base attacks. neighboring hydrogen. This was the neighboring hydrogen. This was the neighboring hydrogen. So base attacks here. But what does it do? Base attacks the neighboring hydrogen. Yes, forcing. What is force really? Forcing the electron from the from where? Forcing the electron from the carbon bond to make the double bond. Since this mechanism involves what it involves, formation of a carbocation rearrangement can occur. So because carbocation is formed when this halogen leaves and one molecule is involved, so the rearrangement can occur. An example of so we talk about other examples. An example of I'm going to go an example. Yes, where is an example? We're talking about an example of even reaction. Okay, so this is another example. What can you see here? An example of even reaction. Let's go. Let's see example wise. This is another thing. You can see this is halogen. Yes, that's leaving. Okay, so when it leaves, what will happen in the next step? You see the plus charge. Yes, plus charge. Yes, plus charge here. Okay, and same thing happen. These protons form a bond then. Okay, you can see these protons, electrons, from these protons. Yes, two electrons form a double bond here. Okay, you will see in the next step. So this next step is missing, but it will form a double bond. Now we talk about base strength. A strong base not required since it is not involved. It is not determining step. Base is not a determining step. Leaving group. A good leaving group is required, such as halide, since it is involves the rate determining step. Okay, so leaving group is involved because when leaving group leaves, then carbocation is found. Rearrangement, since the mechanism goes through the carbocations, rearrangement can occur. Okay, wow. So this is what we have. Okay,